Hey guys, welcome to episode 8, where I continue the series on developing a Commodore 128 game from start to finish. In this episode, I'll be discussing setting up your VSCode Workspace and the KickAssembler extension for VSCode, and also how to build, run, and debug the C128 code. In the last episode, I started coding without showing you how my environment was set up, so I thought I'd dedicate this episode to that. Going to show you an easy way to download the assembler and emulator. You won't be needing a debugger because we'll be using Vice's built-in debugger. I'll bring up the extension for you here. So we'll go to extensions and we'll search for KickAssembler. And the one we want is KickAssembler 8-Bit Retro Studio by Paul Hocker. The KickAssembler extension written by Paul Hocker is the one that I'm using. You can see that the name is KickAssembler 8-Bit Retro Studio. We'll set up the extension in this episode, but first you need to make sure that you have KickAssembler and a C128 emulator installed on your machine. If you're completely new to the whole process, the next part of this video will guide you. Otherwise, you can skip ahead to the part where I talk about building source code in a PRG file, auto-loading it into Vice from VS Code, and entering debug mode. A caveat here is that we will not be using the very popular C64 Debugger. This will not work for the C128, so we'll be using Vice's monitor program to debug. If you're expecting a visual experience to debugging your C128 games, you won't find that here. I have yet to find a C128 debugger that has similar functionality to that of the C64 debugger. The monitor program that comes with Vice uses a command line interface as opposed to the popular GUI that you would have with the C64 debugger. Still, with Vice's monitor, you can set breakpoints, step through the program, and visualize the graphics progress step by step on the emulator screen. More on this later. So let's start by first installing the VS Code extension if you don't already have it and are new to all of this. Here, I'll assume that you already have VS Code installed on your computer. So when you have the extension window open, hit the install button. Now I already have it installed. Once it's installed for you, you can simply read through the notes on the details tab right here and start installing the programs you need. I'm going to scroll down to the quick start using Vice for the C64. There we have quick start using Vice for the C64. So there's a link provided right here to where you can download and install KickAssembler. We'll click on that. We want to open that, and it'll bring up the KickAssembler website. So on this page, you can download KickAssembler, download the manual, and also download the Java 11 runtime environment. Although anything up to Java 18 will do, I'm using Java 18. I won't go into the steps of downloading a Java runtime. Make sure you have one and it's at version 11 or higher. The highest version I've tested is version 18, and I've had no issues. So go ahead and download KickAssembler. Unzip the folder and place it somewhere on your computer. Make sure you make a note of the path to where you've placed it, as you'll need it later. Right, now back to the quick start guide. You can see that Paul also provides a link to installing Java right here. You can also use that link to install Java. I recommend installing Java 18. Now I'll scroll down to step 3, and here we'll find the link to Vice, where we can download and install the Vice emulator. I'll click on it and navigate to the Vice page. The latest version, as of the date of publishing, is version 3.8. Now, I have personally found one small bug with this version when using my retro Atari joystick. Even so, I'll be using this version and may report a bug when I have a chance. I may move back to version 3.7.5 in a later episode if the bug in 3.8 is preventing us from moving forward. So go ahead and download version 3.8 and place the unzipped folder somewhere on your file system. Make a note of the path, as you'll need this later when configuring the VSCode extension. Heading back now to VS Code. At this point, we have everything we need. You won't need to download the C64 Debugger because we won't be using it. It simply will not work for our C128 code. If you notice any error notifications at the bottom right-hand corner of the window, don't worry. That's because we haven't configured the extension yet. I've already done it, and I'll show you how I've done it. I've configured my extension instance at the workspace level, not at the user level. This makes it easy to share the workspace setting with other users. Strongly recommend that you follow my steps in setting up your workspace. That way you could follow along. Create a folder somewhere on your file system. Here I'm using Windows 11, and I've created a folder called Game Code. Inside the folder, create a subfolder called Emulator and another called Out. The file base.asm that you see here is a small assembly language program I wrote in the last episode. You don't have to create it at this point. We'll look at it again, and you can create it in VS Code. The workspace file can also be created in VS Code. This file is important because it will signal to the VS Code, to VS Code to treat our environment as a workspace and use all settings defined at the workspace level. Settings for the KickAssembler extension will also be stored in this file. Now back to VS Code. Open the folder that you just created by going to File, Open Folder, and select Folder. In my case, I'm opening the game folder that I showed you. You might get some error at the bottom right corner, just like you've seen here. Because again, in your case, and in the case we have now, the extension hasn't been configured. In my case, I haven't opened my workspace that contains the KickAssembler extension settings, so just ignore the errors for now. Now, we're going to expand the emulator window folder. And just a note before continuing further, I found that issues can arise with the extension from version to version, both with Vice and the extension itself, when using the extension's options to inject a PRG program into Vice's RAM and auto-run it. Also, at this point, I can't figure out why the extension cannot successfully pass label and debug information to Vice. For me, I'm failing to get it to work. The reason could be that it's really not supposed to work that way. When reading the Vice manual, nowhere is it mentioned that you can run Vice's X128.exe program with a PRG file passed as a parameter. Only a D64 file can be passed as a parameter, and any program in the D64 image can auto-run after the D64 image is loaded. So instead of calling the emulator directly from the extension, I've created an MS-DOS batch script to create a D64 disk image, save the assembled program to it, and then run Vice's Commodore 128 emulator while passing it the parameters needed to auto-run and debug the program. I'll explain this in more detail next. Now start by creating a file in the emulator folder and call it x128.bat. This is a shell script for running the C128 emulator with some parameters. but also setting things up so that we can have the ability to debug our code. This is what the script looks like. There are two CLI programs that are run from this script, C1541 or C1541 and X128. By default, these are not in your Windows path variable. So that needs to be adjusted to include the paths and those two programs. So add these lines to the x128.bat file. Okay, so the C1541 program lets you create a disk image. Attach that disk image and write a PRG file to that disk image. This first line creates an MS-DOS file called disk.d64, which contains a D64 disk image. In other words, the file represents a floppy disk. Here, I'm making the header to be disk and the ID to be 00. And I'm telling C1541 to create the disk image in D64 format, the format commonly used for the Commodore 64 and Commodore 128. This line attaches the newly created D64 image to the C1541 emulator and then writes the Commodore 128 program base.prg to the disk image with the name base. Recall that base.asm is the program we're working on in this series. The base.prg file will be created by KickAssembler, and that step will be run before x128.bat runs. Recall that x128.bat replaces x128.exe as our emulator, but of course, it calls x128.exe on the last line. This line is not needed, but I've kept it here in the event that I wish to run this batch program on the command line. The line will simply list the contents of the D64 image. Okay, moving along to the fourth line. This line does four things. It sets the auto start mode to 1, which injects the PRG file into RAM. It attaches the D64 image that was created from the first line and auto runs the first program on the disk image, which happens to be the only program, base.prg, that was added in the second line. The fourth thing it does is executes the commands from the file base.vs in the device monitor after starting up. The file base.vs will be created when building the assembly file. It will contain commands for adding labels and breakpoints in the device monitor. More on this later. Once we build our basic assembly program, we'll browse the contents of base.vs. That's it for the batch script. This can also be run directly on the command line right after you build your assembly file into a PRG, but we'll let the KickAssembler extension run this. The next step is to configure the extension, but instead of using VSCode's GUI for setting the parameters, you're going to create a code-workspace file. Okay, so next, you need to create a file, and it has to have a extension of code-workspace. In my case, the file is named episode8.code-workspace. In your file, you should have similar contents, but you'll need to change the paths to point to where you're keeping your files. The first parameter sets the location to the emulator runtime. This is the full path to this x128.bat file that you just saw. Emulator options should be cleared. And that's why I have line 9 there, to be sure the extension doesn't revert to the default setting, which we don't want. Next, on this line, is the full path to the jar file of KickAssembler. Be sure to use your path. The next parameter is optional, but I'm doing it here. It's to tell KickAssembler to put all builds into the out folder, and by builds I don't mean just the PRG file, but also the D64 image and the symbols file. I don't need the debugger dump file at this stage, so I have it disabled by setting the debugger dump file parameter to false. I like showing diagnostics, so I've set this parameter to true. And finally, we have the full path to the Java runtime. Once you have the file created and saved, close the folder. We'll go to File, close folder. Then we'll go to File, open Workspace from File, and select the code-workspace file. In my case, it's episode 8.code-workspace. So the workspace and all settings attached to the workspace will be loaded, which in our case are the settings for the KickAssembler extension. You'll see the errors at the bottom right of the screen disappear, because now the extension knows where to look for KickAssembler thanks to the settings attached to the workspace. Now at this stage we can build and run our assembly program, but I'll just build it for now to show you the files it puts in the out folder. So hit Control-Shift-B to build the program. Control-Shift-B. In the Output tab at the bottom, you'll see that KickAssembler has created base.vs and base.sim. We only care about base.vs as this will be passed to Vice as monitor commands. Then, of course, if we look at the out folder, we'll see our base.prg program. Now let's look at the base.vs file. So we'll open the base.vs file here. And without getting into too much detail, you can see that the base.vs file has some lines. These lines are commands for Vice's monitor. Just to be clear, I'm not talking about a display monitor. I'm talking about the terminal program supplied with Vice that allows us to look at the contents of memory and registers, set breakpoints, and step through the program, essentially debugging through it. So the first line is a command to add a label to the monitor called start. Recall that we have a start label in our program, right? Here's the start label, which represents the address 1C19. The next line adds the label upstart end. Finally, the last line adds a breakpoint at address 1C19. Now, back to our assembly program. So we're breaking right at the start label here. You can see the break. We're breaking right at the start label, at which the command jump start resides. This is all that's needed to be able to build, run, and debug. So now hit the F6 key, which will build and run our base.asm program. So it's building, and it's also going to bring up the emulator and the monitor window. So I'll switch views for you so you can see that. Now you can see that the Vice monitor has appeared and that the breakpoint I set has triggered. So the system is stopped at address 1C19, which I labeled start and contains the instructions jump start. In the Vice monitor, labels are preceded by a period. Now that I'm in the Vice monitor, let's have a look around memory. I'm going to have a look at memory starting from address 1C01, which is the start of BASIC. To look at the contents of memory, use the command M followed by the address. the contents for a default number of addresses will be displayed. And type M1C01. So it may not be easy to see, but the small basic program that was inserted into memory starting at address 1C01 appears here. Looking back at the assembly program at line 13, the first word will be the address of the next line of basic. In this case, it's labeled by upstart end. Without having to do the math in our heads, I can just issue a vice monitor command, SHL, which stands for show labels. So I'll type that in, SHL. And you can see that the label upstart end is for address 1C0B. An address on the Commodore 64 and 128 is stored as little endian, meaning the second byte of the address is stored first in memory, and the first byte of the address is stored second in memory. So the bytes are flipped. So the address we are storing at address 1C01 is 1C0B. The byte 0B is stored at location 1C01, and the byte 1C is stored at the next location, location 1C02. The next word is 0A00. BASIC also stores its line numbers in little endian, meaning the value is actually 000A, which is hex for 10 and is the basic line number, which we can see at line 14 in our assembly language program. We've asked the assembler to put the word 10 at that address. The next byte is the code for the basic sys command, hex 9E. Which was inserted by line 15 of the assembly language program. We look at, if we look at line 15, we can see we've asked the assembler to place the hex value 9E at that address. Now the sys command takes an address, but the address needs to be in decimal and then converted to a text string. So the address is passed to the sys command, is the address with the label start, which is 1C19. Converting that into decimal, we have 7193. Converting that to an ASCII string, we would have the values, or the hex values, 37, 31, 39, 33. Which is exactly what we see for the next 4 bytes. Then we have a 0 byte followed by 2 other 0 bytes to end the program. Then we can see the hello world string that was defined in line 3 of the program. There's our hello world string. Finally, I'll show you how to advance to the next instruction, and that's using the next or N command. So we'll type N. Notice that I'm presented with the jump instruction in line 8. This is saying that the next instruction will be the same as the previous instruction that was run, and that's because the next instruction is itself. It's basically an endless loop. So that pretty much covers what I wanted to in this episode. I've showed you how to install the VSCode extension for KickAssembler, KickAssembler itself, and the Vice emulator. Then I showed you how to create a batch script to create a D64 image, save the base.prg file to it, and then run the Vice C128 emulator while auto-loading and running the program and sending label and debug commands to the Vice monitor to trigger a debugging session. Finally, I showed you how to create a workspace in VS Code, while configuring the KickAssembler extension for the workspace. Now, I know this wasn't as fun as building the game code, but that will come in the next episode. I should say the next episode in the series. I didn't want to leave the absolute beginners behind, and so hopefully this was helpful for you guys. In the next episode in the series, I won't actually be showing much code, but instead dive right into creating a sprite. For that, I'll be using a program called SpritePad, which you may already be familiar with. However, in the next channel episode, I'll be setting up my European pet 8032 to work on my North American power main. I'll need to swap out the 50 Hz European editor ROM for the 60 Hz North American editor ROM and use a step-up transformer to boost the voltage up to the standard European 220 volt power mains. It'll be a live test, as it will be the first time doing it. That's it for this episode, guys. I hope you liked the episode and see you on the next one.